So this is a Curtis Industries Model 14 Keycutter from about the 1930s. This is when it was at least initially patented. They, I think, kept making these for many years. If you want to look at the patents for this, you can see that it has two U.S. patents, U.S. patent 1995798, and also slightly harder to read, U.S. patent 2626663. So I'm going to tell you a little bit about this. This is a pretty interesting little device. So usually when we need a key, our typical experience is that we have a key we already know works on the lock. And we take that key to a hardware store, or we take it to a kiosk in a mall or something like this, and we get a copy of the key made. Sometimes it's an automated process. Sometimes a person sits there with a funky machine. But in either case, it's a copying process, right? You're not making a new key out of nothing. You're copying an existing key. Maybe you got from your landlord, it's the key to your car, whatever. But what if you need a key and you don't have anything to copy? So one way you can originate a key, it's called, is you can file it. Right? So you can take a blank key and the file, and you find the spot where you need a groove to be cut, and you just sort of keep filing and filing and filing slowly. You got to be precise, make sure it doesn't move. And you just file, and you hope when you're done that you've put the grooves in the right place and you've gotten them to the right depth. You can see with a little bit of filing, now we've got like a very tiny little notch cut into it. And you just do this down the whole length of the key for each of the positions you need and each of the depths that you need. And this can be somewhat tedious, right? Like filing out all of this material, you're gonna have to sit here for like 20-30 minutes, maybe longer, just to cut these. And these are pretty shallow cuts, at least with the settings that I used. So filing by hand, it's totally possible. That's a perfectly valid way of originating a key, but it's also extremely time consuming. Another way is to use a machine like this, use a little Keycutter like this. This one is specifically designed for originating keys. You can use it for copying keys if you know the code. So if you look at this, the depths that these cuts go to corresponds to a specific number. And if you know that number, you could then make a copy of this simply by originating another key that has the same code. But because this machine is not designed to use one key as a template, we usually say that this originates keys no matter what you're doing with it. So here I've stripped the Keycutter down to its sort of bare minimum. The business end is right in here. You can see as I squeeze this trigger handle thing, a little piece moves back and forth. That's the cutter, and every time you squeeze, it will take a nibble out of the key. The key itself gets mounted into this piece. So on the back of this, there's this there's like a gripper thing and a little some grooves, and it fits the key. And now it holds on. The groove is dependent on the key, but I think that this particular groove, this is a Schlage key, I think this particular groove is actually pretty common. So this holder fits it. You can also see that there are these, there are some teeth. So the top here forms a rack that is worked by the pinion on the end of this knob. And you can also see that there are 5 little notches. And those notches interact with the wire that you can see here that is held in place by this rivet. And those act as positional detents, so you can index this at each of the positions that it has to cut a notch for a pin. Those positions are marked on the front. You can see it starts at 2, not at 1, and it goes up to CA. I don't really know what CA stands for. But this, you can see, has 5 different positions. So what you do is you put the key in here, and then once it sort of starts engaging the pinion, you can you can draw it in. Now this actually is a little bit high right now, so, or a little bit low, so that makes it easier to raise it up. I guess technically it's lowering it because this position is for shallow cuts. But you pull the key in until it's flush, and this is the 1 position. And every time you squeeze this, I'm going to move this a little bit up like this. Every time you squeeze this, it takes a little nibble. So you can see there's a piece that came out, shot out that hole on the end, and that's that. Right? So you put it in, you put the key in, you take a bite, and then you move it 1 position. Now it shows 2, so you can see that you're on 2. Change the depth, take another nibble, go to the next position, change the depth, take a nibble. Now the deeper the cut, the harder it is to actually do the cut. So if I try to put this as far down as I can get it, I don't even know if I can do that in a single cut. Yeah, I think it won't let me go further unless I've cut a little bit. It's harder to nibble more. It's hard to cut a deeper cut in one go than a shallow cut. So really the pattern is that you take a bite and then you increase the depth. You take a bite, you increase the depth, and you keep doing that until you're at the right depth. So how do you know what the right depth is? Well, that's where this piece comes in. You can see on this post, there's a little, there's like a post up at the top. There's a detent, and then there's this little thing. On the back of this, there's a pin. You can see right there. There's a pin. And that's the reason that there's this mark here. And what happens is you take this wheel. This wheel goes in here. Raise the pin so they can go in. The pin then can sit in this track on the outside, so you can rotate this. And then you can select the depth by, let's go with this one. This one has some fine numbers. You select the depth that you want to cut to by lining up the pin with a collection of holes, like these, and then moving it out of the track and into those holes. So now that's at 1, and if you take a nibble, it'll be at that depth. Now it's at 2, now it's at 3, and so on. So it's relatively simple conceptually, right? If you want to take a depth, let's say the 5th position, we want that to be a depth 4, you would take a depth 1 nibble, and then maybe a depth 3, and then a depth 4. And now when you look at position 5, you can see it's cut rather deeply. That's too deep for this particular kind of key. At least I think it is. Yeah, you can see at the very end how the wall is now vertical, and it's not like this other one where the angle meets the top. Here at the very end, you can see the angle does not meet the top. It goes a little bit vertical. That's too deep for like a Schlage key, right? The moment that the wall goes vertical, the pins will just get stuck, and so you basically have a lockout key. That could be intentional. So maybe they want to be able to lock people out of their houses or something like this with this. But normally you wouldn't use that depth. Okay, so let's discuss how the key holder and the wheel correspond to a particular brand of key. So you can see that this has 5 positions that it can cut. That means that this can only cut keys for 5-pin locks. The spacing of those positions is also determined by those detents, and so it can only cut keys for locks that have that spacing. The depth is determined by the angle. The depth of the cut is determined by the angle of the arm, and that means it's determined by the positioning of these holes. So you can see that this wheel, right, this wheel has many different kinds of holes, and so you can cut keys for many different kinds of locks with a single wheel. And that's very convenient. You could obviously then swap out wheels for different locks or whatever. I haven't been able to find any information actually on these just these long slots and why the numbers are upside down. No idea. But you'll also notice that the numbers are sort of related to opposite sides. So this says YLR here, and then it has YLR up at the top. And then the upside down bit here says GM. I assume that's for like General Motors. So I think this is used for cutting car keys. But there's another upside down GM over here. I wouldn't be surprised if this is actually for testing the keys, right? If you need to measure, if you need to find out what those settings are, what those depths are, you can probably just put the key in and then slide it down here to test. I'm not sure that I fully buy that. Let's see, we cut on the BS here, so we should be able to find, well, this says BS, so I should be able to put this in and slide it all the way down, and well, it doesn't fit. Now, it's probably just because this key is not the right size for whatever this brand of car is, right? So that's entirely possible. But these could be used for decoding. This is not uncommon, this kind of shape where you have like a wedge with numbers. This is not uncommon in locksmithing and lock sport and whatever to have such a device for decoding keys. But that's not documented anywhere, so I don't know. That's just an assumption. Okay, so obviously this is swappable, so this machine can be used for many different kinds of keys or whatever. You just need the appropriate discs. But you also need an appropriate key holder. And so you would find people with like drawers full of these, right? You'd have like 10 different ones for the 10 different kinds of keys that you cut on a regular basis, and you'd have to swap them out. It could in fact be that that's what the CA stands for. I don't see CA on here, but that doesn't mean much, right? The CA here could just be the key set that this goes with, and it's just mismatched. I have another disc that has more or less the same things. It came with 2 of them. I don't know. I'm not sure what the slots are for, and I'm not sure what the CA stands for. But let's talk about how you could actually use these positions to decode a key instead of using the slots. So let's suppose you have a key and you don't know what the code on it is. You would insert the key into the holder, insert it into the Keycutter, move the key itself into the 1 position, move the depthing arm into the track so that the key itself is as far out of the way as possible, and you can then squeeze this without any risk of cutting anything. You shouldn't be able to cut the key when it's in this position. I don't know for certain if this is not the case on some keys, but you know, this is supposed to be the position that's kind of neutral, so this should be safe. And with this squeeze, you keep it squeezed. You then lower the depthing arm to the position that it fits best. So I can get it into 1. Can't really get it past that. So the first position on this key must be a 1. Now I will lower it back to the track, advance the key to position 2, and do this again. For this position, I seem to be able to get it to is 3. Lower that back down. And see, that's where it's a bit dubious because I couldn't actually advance the key. So sometimes you have to release, advance it, and go again. You shouldn't ever actually be cutting the key if it's in the track, but that doesn't mean that there aren't parts of the key that it interferes with. Move this as far as I can. That seems to be 1 again. So our code so far is 131. Try to move it. Okay, I'm gonna have to release this again. Now we're in the 4th position, try to move it. It's only going to 2. Okay. 5th position is only going to 1. Okay. So it looks like the code on this key read, I'll turn it this way, read from the shoulder out is 1, 3, 1, 2, 1. And that is in fact the code that I used to cut this key. So you can use this machine to decode as well as to originate the key. This can be very, very handy if you don't know what the code on the key is, right? So if you need to duplicate a key and you don't have a duplicating machine, but you have one of these, you can just decode it and then recut it. The only trick here is that you need an appropriate disk and an appropriate key holder for the key set that you're using, right? So this is a Schlage, and that's none of those. Even though it fits into the key holder, everything else about it is wrong. So that's unfortunate, right? That's a flaw of this kind of machine. It could be improved, obviously. For instance, over here you could have like a measurement that will tell you precisely how deep a cut is going to be, and that would be key independent, right? That'd be key set independent. The depth is whatever the depth is, and as long as you know the appropriate depths for the different pins, you would be able to cut any key set that you need to. Similarly, this piece, instead of a rack and pinion and indexing, you could actually just move it back and forth using an arm like this, right? So if this arm can move it up and down, there's no reason that another arm couldn't move the key back and forth. If you wanted to keep wheels like this to make it easy as a reference, that'd be perfectly feasible. But you could also have, in that situation, you could then have a wheel also for the indexing instead of having this piece be indexed. But you would also have the ability to put a number, like you put the actual depth measurements, not depth measurements, the distance measurements, the separation measurements, onto the second wheel, and then you would be able to cut as many pins as you need. So there's some improvements that you could make to this that would obviously make it bulkier, because then you'd have a wheel that sits this way and you'd have an arm that moves this way. Another improvement might be to replace a squeeze cutter like this with maybe a screw that you screw into it. That'll make it less dependent on grip strength. It's not that bad, but some people might not have a strong grip, and a screw would be easier to use. But yeah, so that's the Curtis Industries Model 14 Keycutter. At some point in the future, I'm probably going to try to make a wheel that will work for this. I might try to make a holder, but that's a little bit trickier because it requires some fiddly machining to get that keyway shape just right. But it probably doesn't have to be perfect, because it just needs to hold this. It doesn't really need to fit, right? It just needs to grip this upper little ridge here and hold it in place. These notches are a bit fiddly, so trying to machine those on like a mill, it's doable, but you probably need like a cutting wheel of some sort. and that would probably be a custom thing that I'd have to make. So we'll see. I'll start with just trying to make this at some point. So that's it for this time. Let me know if you found this interesting. I have a bunch of other cool little tools that I'm probably gonna show off in future videos.